All right, hello and welcome. My name is Bob Wilkinson. I'm the general manager for Amazon CloudWatch. Such an exciting time to be here at reInvent with all of you customers and partners in the audience. We're here today to talk about CloudWatch Logs and Lambda, two services we're pretty excited about. So just as a quick audience poll to level set here, how many of you are CloudWatch Logs users today? All right, love all those hands. I'd say definitely over half. Now what about Lambda? How many of you use Lambda in some context? All right, almost as many. Now here's the key question. How many of you have done both? How many of you have done a Lambda function with your logs in some way? All right, pretty small, so it looks like you might be in the right place. I hope we have some really interesting things for you. And of course, these are going to be focused on monitoring and how we are going to give you some new tools to do more with monitoring and tailor these monitoring use cases for your needs. So what we'll do first is I'd like to spend just a few minutes talking about industry trends and monitoring. I think these are important because it really informs us, why we have to think about monitoring, why it's important, and what we're doing about it as CloudWatch. Next, we'll just briefly talk about what is CloudWatch and CloudWatch Logs, a little bit intro to Lambda as well, just to level set for the more important part of the talk. And then I'll be joined by my colleague, Robert Waugh, who's going to walk us through 3 specific use cases that we'll show you. So the first scenario will be about centralizing logs. So this will be a way to take logs or log data that may be in S3 and centralize it in CloudWatch Logs so that you can use the features of CloudWatch Logs. The second scenario is a way to enrich alarms. So it's a way to take the basic alarm notification out of CloudWatch Alarms, enrich that with other information that makes it more actionable, gives your users and operators more context when they get that alarm. And then last, we'll show you how to build an on-demand and scalable Elasticsearch cluster. So this is a use case where you may want to do a specific data analysis, not keep that cluster running all the time, not bear the management burden of that, but just you have a particular window of data you'd like to get to Elasticsearch and do some deeper analysis. All right, so I'm going to start with a meme, if you bear with me. Now, if you ever haven't even seen the This Is Fine Dog, I think my colleagues told me this is the most popular meme of 2016. I don't know if that's true or not, but I think this applies in a lot of contexts, and I would submit to you that this dog has a monitoring problem. Does he not? I mean, how many times have we been in a situation we think everything's okay, but actually it's not? So let's walk through a little scenario. This is a true story. I've changed some names to protect the innocent. All right, so you own Important App. Seems like everything's okay, right? You didn't know anything was going on. Customer writes a ticket, says Important App is down. Well, this is news. So John, the on-call developer, is paged. He starts to engage. None of your alarms fired here. You didn't know what was going on. And what I've tried to do on each step of our scenario here is capture the predominant emotion that's going through. And I would suggest here, it's blissful ignorance, right? It's fine. We didn't even know anything was going on. Turns out something is going on. All right, so John, the operator, starts to engage, starts to look at dashboards. Remember, he didn't have an alarm, so he's not directly pointed to a runbook. He's sort of looking at the dashboards, trying to discern what's going on. He does see some sort of impact. He sees some intermittent availability impact on the dashboard. He's not sure really how many customers might be affected or really where to begin troubleshooting. I think he makes a good call here. He escalates to a manager on call. So here, I think we're in a state of confusion, right? John really doesn't know what's going on. Made a good step to escalate to his manager. All right, more tickets are pouring in here. So this does appear to be a pretty real incident. More things are happening. Our escalation manager, Jane, has joined the event. She starts to help too, starts to try to assess the situation impact. Lo and behold, their CTO has also noticed this through watching something else. He said, Jane, what's going on with Important App? Now, I don't know about you, but I've been in situations like this, and I start to feel stress here, right? The thing you own is down. Customers are having problems. You're not living up to your expectations. This gets quite stressful. All right, so now John and Jane, of course, they're on the hook here. They recall there was some recent issue where they saw some customers that were issuing expensive operations. They say, well, maybe that's what's going on here. Maybe there's a customer that's changed their behavior. John starts to log dive. Unfortunately, this wasn't a log that they had put in CloudWatch Logs or some other source for the centralized. So he's on the host. He's running greps, trying to figure something out. They identify maybe a customer that might be doing something. John sees some expensive queries in the logs. So they run through the process here. Jane cuts a ticket to that team saying, hey, please stop whatever you're doing. John's going to go ahead and prepare a change to blacklist this customer. Now, they don't know it yet, but actually this is false hope, right? We don't really know if this was what's going on. Turns out it was not. So the other team engages, said they hasn't done anything. There was no deployment. They didn't change anything. That application was always doing those queries. And then John and Jane confirm the same thing when after they deploy this blacklist, the event still continues. They're still seeing this intermittent availability impact. They're kind of out of ideas here, and John says, you know what, we have a standby, let's just fail over. It can't hurt, right? All right, here, I would suggest we're probably at the stage of desperation. Now, in this case, there's a happy ending here. That actually does work. So the failover worked, important app recovers, yay, life is good. John and Jane pursue through a pretty good root cause process. Turns out a few weeks ago, they'd used a new JDBC version. There was different semantics around closing connections in that version, introduced a memory leak, led to Java heap exhaustion. GC pauses was causing these availability impacts. So they fixed the leak. They add the alarms, the memory usage, of course, that probably should have been there. They tuned the service alarms, right? We were missing this. It was an intermittent impact, so our service alarms didn't tell us something was going on there like it should have. We've reached maybe a state of enlightenment here, but I would say, can we do better than this, right? Is this really the state of monitoring and where it should be today? And I don't think so, and I'll call it a few things here. I think there's probably more. But often we have missing alarms, and a lot of the times when we have those alarms, they're not as actionable as they could be. Now, if you remember, that's going to be one of our demos. The second demo will be how do we take our alarms and make them more actionable using Lambda in this case. Second case, often we don't have the right logs, maybe also not the right metrics in this case, but we also don't have the right logs, and interacting with them can be tedious. And so another one of the demo scenarios will be about how to take information that may reside somewhere else and put it in a place such as CloudWatch logs where you can use it to interact with it in real time. And then finally, our dashboards aren't always telling us enough information about customer impact or the behavior changes that they're making. So if you remember in this scenario, we sort of started out, we weren't sure, we knew there was something going on, we didn't know how many customers were being impacted, and we can do better here too. Now, we won't cover this in the demo today, but hopefully maybe can come back and tell you about that sometime soon. So I think hopefully we've seen through this. Obviously, monitoring is super important, right? If we had the right monitoring in place, hopefully we could have seen this case before it ever started, before it ever impacted customers. But also we start to see why this is really hard. So let's take one step back and talk about these more macro trends in the industry that's making monitoring really hard right now. One is that complexity is increasing, right? Our applications are built off microservices, so lots of components, lots of microservices. We heard a lot about that in the keynote today. Applications are written in different languages and frameworks. They're increasingly running on transient resources like containers and serverless compute, which we're going to talk about today. There's specialization in the persistence tier. It's not just apps built on relational databases anymore, right? We know this, that there's NoSQL databases and SQL databases and in-memory databases and every database under the sun. Applications are more dynamic, right? We also saw this in the keynote as well today. But we're testing and building and deploying small changes. So we're rapidly changing our application. And as the scale and design of all these things are changing, so are the infrastructure needs to go along with it. Applications are global, and with that comes customer behavior that's increasingly unpredictable. And then we know that the role of automation is increasing, right? We need to automate more and more of our processes, but this means this is also magnifying all those changes, so our monitoring has to keep up. Next, maybe speaking to why monitoring is so important, but there's more and more business impact. It's undeniable, right? The role of applications in business outcomes such as revenue, costs, and SLA. We know that businesses everywhere are having to evolve themselves to maintain and gain competitive advantage. And undeniably, we all have increased the expectations from our customers for the applications and services that we're building. And the last trend, I think, is that monitoring is no longer a standalone thing because of all these other trends. You know, we used to roll up a server and put some software on it. Maybe we create a static dashboard and then just watch that dashboard once a week and life was good. But it's not like that anymore, and we know that. Right? We're provisioning resources, containers, and instances, and using Lambda, and these things are being provisioned in real time. We have to configure them in real time and monitor them in real time. So there are all these trends that are making monitoring increasingly important, but also increasingly hard. So as CloudWatch, what are we doing about this? So CloudWatch today, it's a portfolio of tools covering metrics, alarms, logs, events, dashboards. There'll be more over time. But how we think about this is really these four areas I'd like to talk about, which is to help you see, then react, diagnose, ultimately to resolve whatever problems may be impacting your applications and services. So first, to see. So what we're doing today, CloudWatch today gives you metrics, logs, events from all your AWS resources that you're using. And we'll have a constant list of these, the growing list of these over time. We'll probably more and more. Now, of course, in each case as well, these metrics, logs, and events, you can do your own. You can do your own custom from the APIs that we provide. Now, what you'll see from us over the near term in this area will be easier tools to collect and publish metrics and logs. So increasing amount of agents and SDKs that we provide to make it easier to get the metrics that you need from your applications and services. So next, with all that data that you're seeing, you have to be able to react to that and do that in increasingly intelligent ways. So today, of course, you can define an alarm, which is the ability to look at a metric. You define a threshold that crosses the threshold, and you can trigger some action. Similarly, you can write an event rule. So you can say, when I see this event, I'd like to take this particular action off in a Lambda function. In this area, we'll be providing more and smarter ways to act on these things. So think of it, more advanced trigger criteria for alarms. We're looking at how to do prediction-based alarms. We can alarm on prediction bands and things. Well, these are all things you'll see from us over the relatively near-term roadmap that we're doing. Now, when we look to diagnose, right after you've reacted, so you know something is going on, but now I have to figure out what's going on. And ideally, hopefully this becomes automated as well. But so here you have tools like CloudWatch dashboards that are allowing you to inspect, navigate, zoom across your data. Something we did recently was the announcement of metrics to logs. So since we launched the log service, there was always the ability to generate metrics from those log streams. We now gave you a tool to jump from a metric graph or a dashboard into the particular logs that generated that metric. So it's a really common troubleshooting pattern that we see is when you see a point on a dashboard you'd like to investigate, well, what were the logs actually telling me to get those more details of what's going on there? Now last, as I said, hopefully all of this really is about resolving problems faster and with less effort. And increasingly we see that over time where we need to head as a community is we have to make this automated, right? So in many cases, what we'll hope to be eventually is that we can detect these problems before they're ever impacting customers and do something about it, take those actions. So today we give you tools such as, again, CloudWatch Actions. We'll show you ways to do with Lambda that you'll be able to do that. But increasingly looking at this to need to be automated. All right, so just briefly, if you've been paying attention, we have done quite a few announcements. I'll run through them quickly. We announced the metrics price drop. We think you need more metrics, and we hope that a new price helps you to do that. As I said, will there be more metrics, logs, and event sources? I haven't listed them all. There's always going to be a long list of these coming out. I mentioned the metrics to logs navigation, so this is sort of graphically shown where you're looking at a metric graph and able to drill it to the logs. We upgraded our metric retention from 2 weeks out to 15 months. This was done automatically. It will actually grow to 15 months over time. We didn't want to wait 15 months to launch it, just so all that history was there. Werner mentioned this morning, but we support arbitrary metric percentile. So this is the ability to look at something like EOB request latency and see the difference between your P50 or your average and your P90 or P99 or whatever value makes sense. You'll often see a graph like is on the upper right where that P50 may be a relatively flat line, but you're seeing something interesting at the higher percentile values of the P99. We find that that's a really important tool, and it's one of the important tools that we use to manage our services internally to Amazon. To help with that C aspect, we released an open source plugin for CollectD that helps you publish on-host metrics about your processes, your instances, and whatnot into CloudWatch. We've had a number of improvements in dashboards over the years. So we had new widgets, a dark theme, y-axis limits. I don't know if anybody's had a chance to play around with the new widgets we launched about a month ago. And then a little bit earlier in the year, we revamped our logs console. So we had a lot of feedback from you that our logs console needed to be more usable. So we revamped that and had a lot of good feedback on that. I hope that's helped you to interact with your logs in real time. Now, I spent a lot of time talking about CloudWatch, but really it's important to know here, this is not just about what's inside CloudWatch. We've said monitoring is hard, it's really hard, and every enterprise team situation is gonna have unique needs. And so, any discussion of CloudWatch is really not complete without discussion of our partner ecosystem. It's really important. We've got partners in the APM space, in the log analytics space, in the operational dashboarding space, and these are all helping you to do, helping you to meet these unique needs that you have, because it's never just gonna be what's inside CloudWatch. And yet, maybe equally as importantly, is that we give you the tools and flexibility to integrate CloudWatch with other AWS services. And of course, we're going to see that here shortly with Robert. He's going to walk us through some of this, but there's a lot of powerful ways to integrate these different things and really tailor the monitoring to your own needs and your own business needs and your own application needs. So I'm going to dive just a bit deeper into the two services we're talking today before I hand it over to Robert. So first, CloudWatch Logs. It's a managed log service. It was built for arbitrary scale, availability, durability, and security. What customers are doing today first is centralizing their logs. So I've shown ingress options over to the left. We have a logs agent that you can install in any host, any agent. This allows you to point it at a log file and stream those logs in near real time. We've done native integration with a number of AWS services. Again, this will be growing over time. Some of the more popular ones today are CloudTrail, VPC Flow Logs, Lambda, ECS logs, was mentioned in the keynote this morning. By having all those logs centralized, what you get is you get the ability to search those, so you can run text searches in near real time. And as I mentioned, you can also extract metrics from those, which is a powerful feature because you can take a particular data element in a log and have that emitted as a metric, which is then something you can put on a graph, set an alarm on, or to take other action on, which we'll see here shortly. And of course, once they're inside the service, it's retention policies according to what you control. It's secure. Pretty soon, we'll be launching KMS support so that we'll, on top of the encryption we already do inside of logs, you'll be able to use your own KMS keys to encrypt logs. And then equally as interesting is what you can do on the egress side of logs. So again, we know that it's not just about what's in logs and what you can do there now, but we know that there's many tools that you're going to use, and these egress options allow you to do that. So we've integrated with a number of AWS services, including Kinesis, where you can egress a filtered subset of your logs to a Kinesis stream and then consume those in whatever way you'd see fit. We have a built-in integration with Amazon Elasticsearch. So from the console, you can walk through a setup step of pointing, again, a filtered set of your logs at an Elasticsearch cluster. You can associate a Lambda function to your log group or log stream such that you can take a particular action on a log as it's coming through. And then we also have an S3 capability to export. So this is a batch export where you can take a particular time range of data, export it to an S3 bucket. Robert actually used this in one of his demo scenarios. Now, Lambda, just briefly, hopefully you know this as well, but it's a serverless compute, right? We use this buzzword, but it really means that you can run code without having to worry about the tedium of managing servers. Warner did a great job this morning of characterizing some of that. So you write the code, it only runs when you need it to, and you're only paying for when it's running. So at this point, I am going to turn it over to Robert, and he's going to start to walk us through our 3 scenarios.
Thank you, Bob. Hi, I'm Robert Waugh, a service owner for CloudWatch Logs. We wanted to present to you 3 demonstrations, as Bob introduced. Don't worry about copying down the code. We're going to have a link at the end that's a link to the GitHub repository for these examples, so you can customize them for your own purposes. So first, we're going to look at how to centralize logs. Essentially, the problem here is that you've got your logs scattered all over the place. Right? You've got containers, you've got instances, you've got stuff being delivered in S3. And if you think that having a centralized log repository with consistent APIs and access controls and retention policies is important, you need to figure out some way to federate all that data to one place. And once it's in that one place in CloudWatch Logs, you're able to search and filter, extract metrics, and these sort of things. Today, CloudWatch offers an agent for instance logs, and for a lot of services at AWS, and more over time, those can directly integrate with CloudWatch Logs. But there are some products and services that still deliver logs to S3. So how do you get those into your central repository? Essentially, what we're going to do here is we're going to do a demonstration using ELB, which you can configure to send your access logs to S3. We're going to set up a object create event notification to Lambda, which is going to trigger a Lambda function, read the ELB log from S3, and then publish it to CloudWatch Logs. So in this demonstration, we're going to set up a little sample stack. We set up 3 Apache servers, 1 per AZ, as you should always do. And we're going to set up a ELB fronting those 3 Apache servers. We add those 3 Apache servers to our ELB, and we go in and we configure S3 delivery of the access log to our S3 bucket. Now that we have that going, as objects are being created, you have the option to set up a Lambda function to trigger on the S3 object creation. Our Lambda function is going to invoke when an object's created in S3. So ELB is delivering logs into S3, creating objects. Lambda function invokes, wakes up, gets the S3 object out, decompresses it, breaks it up into pieces, and then calls the AWS SDK put log events API for CloudWatch Logs. And you can use this in any of your applications. We have a number of customers that use this API to do file-less logging, to log straight to CloudWatch Logs directly. But in this case, we're going to use it to pull in these S3 objects that ELB has been delivering and putting them to CloudWatch logs. This is an interesting point where you can do some transformation, maybe get some metadata from other services and that sort of stuff, and add it to your logs to annotate as part of that. So now that we've got all this set up, we go in to test it out. We do some accesses, hitting the default page, and we start seeing the ELB logs delivering to S3. And as you see, it's just a collection of compressed files. You're not really able to search them or do anything else with that. However, because our Lambda function's invoking in the background as these things are being created, the data is flowing in near real time into your CloudWatch logs console, and now you can see the timeline series, the data organized in a way that's a little easier to deal with in a collection of compressed files. We're able to, for instance, search the data. In this case, we're searching for GET requests for the last day. And we're also able to extract metrics out of the data such that when your access logs land, you post to the metrics service. So in this case, let's say we're going to look for requests that had latencies greater than 1 millisecond. And we want to keep a count of how many requests are breaching our expected SLAs. We define our ELB latency filter. And this is a counting metric. We assign it a default value of 1. As you see below here, if you've configured your metric filter, you can also choose a bunch of other things. For instance, you can pull out status codes or received bytes sent and emit those into a metric. Now, as the log data is landing into the S3 bucket being triggered, triggering the Lambda function, which is putting in CloudWatch logs. CloudWatch logs is extracting a metric out of that for these high latency requests. And we can see our high latency requests here in this graph. With the changes that Bob mentioned on metrics to logs, you'd be able to narrow in on a spike in your latencies, and then ask it to take you straight to those log entries and only show you the log entries that are above your latency threshold. So in this, using this demonstration, you're able to now centralize any of your logs that are being delivered in S3 alongside your instance logs using our agent or logs delivered from Amazon services. You're able to search and extract from these logs in near real time. In our second demonstration, we're going to look at customizing alarms. Today, when you receive an alarm, you may not have all the information that you need from your business attached to the alarm. We include information that we think is helpful to you as a customer, but it's very general purpose. We don't know your specific needs, so it may not be actionable enough if you have special information that you'd like to put in there. Because ultimately, when you get paged, let's say you're out to dinner, and you get a page, and it's really not the best time to dive into your laptop, it's really helpful to be able to look at your page and see the context of what was going on. And you can make a decision whether it needs immediate attention or you can defer it, or it's possibly something that you need to escalate and rotate to another service operator team. And you can do that action if you can get it right there on the initial alert. You may also want to add your runbooks and other metadata and information to your alarms so that your operators can know very quickly where to get started and what's expected given this type of alarm. So in this one, what we're going to do is we're going to generate error logs, which we're sending to CloudWatch logs, and then trigger an alarm off of that, which will be published to an SNS topic. That SNS topic will trigger an event notification in Lambda. And we'll have a Lambda function that's going to pull the information out of the alarm, go back, search the log service for the SLA breach that was emitted from the log service, and invoke SES with those logs to forward on to the operator to tell them in a rich text format with your runbook and everything else attached to it what to do. So similar to the prior thing, we're going to set up a little dummy application. In this case, we're going to set up a Tomcat. We've got our CloudWatch logs agent installed on it, so it's forwarding over the HTTP request in the real time. We see here the timeline of data as it flows through. We go ahead and we set up another metric extraction as we did before. In this case, we want to look for unauthorized access attempts. So we want to see if somebody is trying to penetrate our service. So we look for status code 401 in those logs. Again, this is a counting metric, so we choose the metric value of 1, and we give it a name, unauthorized access filter. Now we're going to go in and we're going to create an alarm based on that. This alarm, as we see, it's after, in one consecutive point, if we see more than 5 unauthorized access attempts, we're going to trigger an alarm notification to our on-call. We now attach a Lambda function to the SNS topic that the alarm notification is going to. And we've created an example Lambda function, which is, again, available in our GitHub repository that we'll show at the end of the deck here. And what this is doing is it's taking the alarm notification from the SNS message. It's pulling out the metric name and the metric namespace, as well as other information such as the time of the alarm. Using that information, we're able to call, actually, sorry, in the previous slide, we're able to call the public API describe metric filters through the AWS SDK, which takes in a metric name and gives you back the log groups and the metric filter definitions attached to it. Now, one of the interesting things about how we've implemented metrics to logs and how logs works is that our search API, our search syntax for searching logs has exactly the same syntax as the syntax used for extracting metrics from logs. So that means you can take that same metric filter definition and apply it to our filter log events API. You remember in the prior slide, we described the metric filters. We got the log group out. We got the filter pattern out. And from the alarm, we know the timestamps that are relevant, like when the alarm stopped, or when the alarm start, and when did it stop. So we're able to call filter log events with these parameters, with the log group that we want to search, with the filter expression that identifies the log entries, and the time range of the alarm. And we get out a sample of log data, which we then generate an email out of by merging in our template for on-call support with both the instance information and the log messages from that particular alarm period, along with, let's say, runbook information, the account, region, other metadata. You could, if you have the instance as the stream name, for instance, you could go out and call EC2 metadata calls and annotate it. So this is a security thing, so maybe you want to put in the security group information and other pieces of data. Test it out. We go in, we generate a bunch of 401s. And we get our alarm. This is the normal alarm that you get today from CloudWatch alarms. It's got essentially all the information you need in it, but it's not necessarily in the format that your on-call needs in order to resolve a problem quickly. Your on-call, however, receives a message that tells them clearly what the alarm was, what the runbook for resolving this sort of situation is, the account, region, other metadata, the time of the alarm, and then it gives them a sample of each of the events that contributed to the alarm being triggered. So with this sort of pattern, you can customize your alarms to add specific details about your issues and customize your alerting to your specific, for your specific business. When you see a spike in metrics, you can also get the logs that were generated when triggering the alarm. And the Lambda function can be extended to add whatever information you'd like. Now we're on to our third demonstration here. In this demonstration, we're going to build an on-demand scalable Elasticsearch cluster. We announced last year our ability to integrate seamlessly with the Amazon Elasticsearch service. The way that works today is that data is flowing in real time. And if you want to do log analysis with the Elasticsearch service using the data delivered from CloudWatch logs, it needs to always be running and accumulating that data in real time. But sometimes we don't want to leave that cluster running all the time. That means that we have just another thing to manage, to scale, to watch, and make sure it's operating correctly. Plus, you're paying for it all the time. And if you're not looking at these logs at all times, it's not a very good use of your budget. And sometimes our logs are not critical logs at all times. Sometimes they're mass amounts of firewall logs or system message logs. And these may be relatively low value to have in an indexed product at all time. But with the CloudWatch logs pricing model, it's affordable to collect them all. But now, if you want to do some sort of deep dive analysis on it, you need to be able to take that historical data from any point in time, export it into an Elasticsearch cluster. And what we're going to show here is a way to do that on demand. So what we do here is we collect CloudWatch logs data over a period of time. Then we're going to go through and we're going to use the export to S3 functionality in CloudWatch logs. Borrowing the pattern that we used in the first demonstration, we're going to trigger on the object create event notifications to Lambda. Then our Lambda function is going to transform the data, restructure it, maybe add in some meta information from other services, similar to what we saw in the prior examples. But you can also break up the log into more detailed pieces for indexing in Elasticsearch through this. And then we're going to forward those logs to the Elasticsearch ATB endpoint. So we first go in and we're going to configure VPC flow logs. For people that aren't familiar with this, this is the ability to capture essentially a span port audit summary for your VPC. It gives you information on source and destination IPs, ports, the amount of data transferred, whether your ACL is accepted or rejected it. A common pattern is making sure that your accept and reject criteria for your VPC access is what you actually believe it to be. So the way you enable these logs is you go into the VPC console, you choose your VPC, and you ask, and there's a flow logs tab where you configure whether you want to get the accept, reject, or all the events, and set up the role for delivery to CloudWatch logs, and which destination log group those logs will go to. Once we've got that configured, in our VPC flow logs log group, we start seeing log streams of information, one per ENI and event level. In this case, this is all the events. You can choose between accept or reject or all. And so we see here we've got all the accept and the rejects in here as well. The log data, it's a little dense and hard to consume as a human being. It's got timestamps, ENIs, IP addresses, port numbers, and all sorts of stuff in there. So we're going to go ahead and set this up into our Elasticsearch cluster. So we go into the Elasticsearch console, and we create an Elasticsearch domain. We set it up with the number of nodes that we need, and the instance types and this sort of things. Click create, and it goes off and starts creating our Elasticsearch cluster for us. In the meantime, we go in and we set up our Lambda function, as we saw in the first demonstration, on S3 object create to trigger a Lambda function. And in our Lambda function, we're going to go ahead and get the S3 object, just as we did in the first demonstration, decompress it, start parsing out the data. And then we transform that into JSON. This is how you ingest into the Elasticsearch service. And you can do whatever customizations you'd like to do here. You can annotate it with meta information about the log itself, and you can query instances. A popular thing in this sort of model is to query the VPC metadata to get ACLs and security group information to attach into the VPC logs to help you with your audits. And then we're going to format this data and put it into the bulk ingestion API for Elasticsearch. It has a HTTP RESTful endpoint, and we're going to take advantage of that to ingest. Now, we've got our Lambda function set up. We've got VPC flow log data flowing into the service. And we're going to trigger an export to our S3 bucket that everything's attached to. We go to the logs console, we select the log group, we go to the actions, and we choose export data S3. In here, you're able to choose the time range that you want to extract from that log group. And you can deliver it to your own bucket in your account, or a common popular thing is to export into a centralized bucket across your accounts and regions. So you can get a cross-regional view and cross-account view of your operations. And if you do that, you'll choose the other account option here. Once we trigger that, the log service diligently goes out there and starts reassembling all of your data into objects that it dumps into your S3 bucket. The prefixes, and it will be by log stream. And so in this case, for VPC data, it's by ENI. Inside of this, you'll find, sort of similar to what you see with the EOB logs, you'll see a bunch of compressed objects that stream in as the log service prepares them. As it's streaming in, remember we're invoking the object create notification in Lambda. The Lambda function is decompressing the data, reformatting it, and posting it to the Elasticsearch cluster. We can start seeing it flow in Kibana. And once you've got everything loaded into your Elasticsearch cluster, you can go in and start doing different sorts of analyses. You can look at like the bytes accepted, rejected, and that sort of stuff to help you see what the surface area of the incident looked like. Let's suppose that we had a network breach 3 months ago that we just realized, and we want to find out what the possible blast radius is. We know which IP an instance was compromised, and we want to see were they reaching out to other things during that time that they would typically would not. So for doing that sort of stuff, we can do more interesting things like top talkers and pairs and these sort of things. So key takeaways on this one. It's often extremely useful to be able to send historical data to an indexed analysis product within a particular time frame. You don't necessarily want to be able to have something running at all times in order to access stuff. And sometimes our data in an index product can't fit all within the working set for the instance, the cluster. And so you need to be rotating data out. But what do you do when you need to do a deep dive root cause analysis? Or what do you do if the data is normally doesn't have enough value to sit into an index product at all times? So this reduces your costs and it reduces your burden of scaling on these Elasticsearch clusters if you're building them in real time, and it reduces your operations time overall. Troubleshooting gets easier too because you're able to narrow the data down to the specific window in which you need, and you have then only the limited and relevant data for the incident response that you're trying to do an analysis on. And with that, I'm going to pass it back to Bob for the recap.
All right, thanks, Robert. So I hope that these scenarios, whether you can use them directly or not, I hope that it's spurred some creative juices on what's possible with CloudWatch logs and Lambda. As we said, monitoring is more important than ever. I think we probably have an innate sense of that, but it's still too hard. And so we need tools like this and techniques like this to work through some of these things. Now, of course, as CloudWatch, if I have to simplify the simple statement of the mission of CloudWatch, I would say we're trying to make monitoring easier, and we're going to roll out features and new services as fast as we can to do that. But ultimately, it is going to be about this broader ecosystem of what you're doing with other AWS services and with other partners. So I should have probably warned everybody we are going to have some time for questions, so please be thinking about questions. Just before we get there, we have some links here. So there's some documentation links. As Robert mentioned, all of the code that we showed, all the Lambda functions are in our GitHub AWS labs now. They're live now. So please go check those out and see if there's anything of there that's of use to you. And of course, evaluations are quite important. We value your feedback, and we use that to get better and better each year as we do these things. So please complete those evaluations. So at this point, I would like to open the floor for a few questions if there are questions out there.